calculator, and I should really get my own actual calculator because I don't know how to convert this into a decimal, or a fraction rather. I don't even know if this is a fraction. Well, I got this value, 0.0412. That is the ninth term. And they got 10 over 43. All right, so they clearly did a fraction. 10 over 43. I guess if you really wanted to do it in fraction form, what I would do is 3 to the power of 8 first, which would be then 3 to the power of 8 is 1 over 6,561. And now I'm multiplying by 270. And now you have to do a common factor. So what's the common factor between 270 and 270 divided by 6,561? That obviously gives me a decimal. So let me see, 6,561 divided by 9. So I can divide both by 9. It's going to be 729. And 270 divided by 9 is 30. I can probably divide both by 3. That's 243. Now we're at 10. And 10 over 243 is the answer because the only factors of 10 are 2 and 5. And you can't divide 243 by 2 because it's not a even number. And you can't divide by 5 because it's not a multiple of 5. So this is the final answer. So that's how you would do it if you want to convert fractions. Simplify fractions, sorry. Oh, that's it. Hey, lesson 1, that wasn't hard. Lesson 2. Okay. Lesson 2, what are we doing? What is lesson 2? Oh, we're doing series now. Okay. So first lesson was sequences. Remember, a sequence is just a pattern. A series now, by definition, actually, let me just read the definition. So in sequence is an ordered list of numbers identified by a pattern or rule that may stop at some time, but that may stop at some number of continue indefinitely. Ugh, annoying. Arithmetic sequence that you have a common difference. Geometric is when you have a common ratio. And series now is the sum of the terms of a sequence. So a series, what we're learning right now, is when you take the sum or when you add up every single term in that pattern. But you're like, if I add up every single term in the pattern, wouldn't that just go to infinity? And you're not wrong. Sometimes series will go to infinity. But we're not always adding every single term. Sometimes we are limiting to just like the first 4 terms or first 10 terms or whatever. So it depends on what the question is asking us. So in this example, we have 2 equations or 3. I don't know. I can't remember. I'm pretty sure there's just 2 actually. All right. So the general formula for a series, arithmetic series, meaning if I'm adding the terms of a arithmetic sequence, if I'm adding them all up together. So Sn is equal to n over 2 brackets 2a plus n minus 1 times d. So you realize that this has this exact same values, or variables rather, as the arithmetic sequence. We just need my a value, we just need my d value, and we just need n. That's it. It's just 3 variables. And we usually have a and d because a is the first value and d is the common difference, so that's not hard. And n is just something the question usually gives you. So yeah. Now we have a general formula for an arithmetic sequence is this, which is something I already showed you. where Tn is equal to A plus n minus 1 times D. And if you plug this part into here, you see how this is n minus 1 D and there's an A here? So if you plug that in, if you substitute it, you can also have a formula that looks like this, where the sum of an arithmetic series is equal to n over 2 brackets A plus Tn. And you use this version when you're given the value of the last term of a series. And hopefully I'll have time enough to show you exactly what that means. But let's do a basic example now. All right, first example to use this equation. You'll notice that in this unit, it's a lot of just knowing the equation and plugging in the known values and just solving. So as long as you have your nice little cheat sheet, reference sheet, with all your formulas, you'll be fine. So here we have 1 plus 3 plus 5 plus 7. So instead of 1 comma 3 comma 5 comma 7, we're basically adding all the terms in the pattern. And what's the pattern? What are they going up by? And this is a very easy pattern. Everyone, I think, can figure this one out. They're all going up by 2's. It's just plus 2, plus 2, plus 2. That means my A value is 1, because that's my first term. My D value is 2, because it's going up by 2's. And it's asking you, find the sum of the first 23 terms. So my N value is 23. So let's do this. S23 is equal to 23 over 2 times 2, or brackets 2 times 1, because A value is 1, plus 23 minus 1 times D, which is 2. So 23 over 2, I'm just going to leave that for now. Solve the bracket. That's going to be 2 plus 23 minus 1 is 22. 22 times 2 is 44. That's going to be 23 times divided by 2 times 46. And obviously you can just divide that by 2, which is 23 as well. So 23 times 23, 500 and something, or is it 6 something? I forgot now. Let me just use the calculator. 529, yeah. All right. So yeah, and I think that is the answer. So let's see if we did it right. Yes, 529. Easy stuff. Example 3. Here we have erase that for now. Okay. Here we have an arithmetic series with 52 terms, with -7 as the first term and the last term as 102. Find the sum of the series. All right, how do we do this? Well, we know that the total terms in the pattern is 52. So I know my n value is 52 because we're trying to add up every single term. So we're adding all the terms from the first term all the way to the 52nd term. We know A value is -7 because say starts with -7. So A value is -7. And we do not have our D value because they didn't tell us by what amount it's going up by. But we do have our last term. And our last term is T52. How do I know it's T52? Because they told us that there's 52 terms. So the last term has to be T52, and that is 102. So what I'm going to do is I'm going to actually solve for D. But how? Remember the generic equation Tn is equal to A plus n minus 1 times D. I think that's the equation. A plus n minus 1. Yeah, that's right. So this is the equation for an arithmetic sequence. And I know that n is equal to 52. So T52 is equal to A, which is -7, plus 52 minus 1 times d.